Okay, so this is going to be the last set of notes for this unit. Okay, we're going to start a new one next week. So we're on unit 8.9. Okay, we're skipping 8.8 if you are sad about that. I'm just sorry for you, okay? So unit 8.9, we're going to be talking about qualitative graphs. Qualitative graphs. Does anyone think they might know? What is a qualitative graph?
One of a kind.
No.
That's an easy.
Qualitative graphs are basically graphs that are talking about a word problem. Okay, so like basically word problem graphs. Okay, so for example number 1, we're going to do 4 of these. Okay, I am going to draw you a graph and just do your best to semi-draw it. Okay, on the right, or excuse me, on this axis is going to be distance from home. And on the bottom is time. Okay, on the bottom is time. So our graph's going to go, and you don't have to have this perfect, just, you know, kind of do your best here. So your graph looks semi-ish like that. It's amazing. Okay. So, I'm going to tell you about this graph that Brian ran, excuse me, sorry, I'm being slow today. Brian ran in preparation for a marathon. So the graph below shows the distance that Brian ran in preparation for a marathon. Okay, what we need to do is describe the change in distance over time. Describe the change in distance over time. So basically for qualitative graphs, we're asking you, I'm going to give you a picture and I'm going to ask you to make up a story that matches with this graph, essentially. Okay, so, and it doesn't have to be like super long or anything like that, okay? I just want to know, so if this is talking about distance from home, so you're running, okay, this is your distance from home over a length of time. What does this mean? Can you give me a scenario here? Is he walking? Is he running slowly? Is he running quick? Is he... Exactly, yeah. So he started running. So literally, there isn't necessarily a right and a wrong answer here. You make up a story, basically. Okay, so we could say that he started jogging. We could make up like a total story here, okay? So he started jogging, okay? So he's like going at a semi-good pace. Then what happened?
He's speeding up.
Speed it up.
Why would he speed up? Let's just make up a reason, huh?
He went down the hill.
A dog was chasing.
Okay, if he went down a hill, so he started jogging. A dog chased him,
Down a hill.
so he went faster.
And he tripped and fell.
No. A dog chased him, so he went faster. Okay, so he started jogging would be like this portion, okay? A dog was chasing him is like this portion, so he went a little bit faster. What happens right here?
Two dogs chase him.
Well, he's not going quite as fast, so he's like getting farther away, but he's not going as fast.
The dog is getting slower.
Well, the dog stopped, basically, okay? So then he slowed down. He slowed down back to jogging pace, because this looks like it's about, you know, like the same pace, right? So he slowed down back to jogging pace. Oh, J-O-G, jogging, sorry. I was talking to myself. Okay, so the third part is he slowed down back to jogging pace.
And then he got home.
Well, and then, like, was he home already? What does this indicate?
Just home.
He stopped. He slowed down.
This is going pretty fast, right? Isn't this like kind of fast how he all of a sudden gets home? So he
ran downhill, literally.
now it doesn't necessarily mean he ran down a hill, but it could be like he like sprinted home. Like, oh, I gotta go. I'm meeting my girlfriend for dinner or something. I don't know. Okay. So then all of a sudden he was really far away and he realized, oh wow, I like really have to run. So the last part is maybe he sprinted home.
You got a farm right over the top.
He sprinted home. Okay. So there's not necessarily a right or a wrong answer here, okay? You're just interpreting what's happening in this graph, okay? Now, you do not say it again.
What's a run story every?
No, not for all of them. Not necessarily, okay? So you do not, by the way, have to write like the parts like this. I was just like labeling them basically, okay? But on your homework and stuff, I'm not requiring that you actually do that, okay? Let's try another one for number 2. Okay, so for number 2, it tells you the graph below, and obviously you don't have it yet, okay? The graph below shows the population of bacteria in a dish. Okay, the graph below shows the population of bacteria in a dish. So population is basically the number of them. Okay, I want you to describe the change in population over time. So describe the change in population over time. Why is it that we're not going to make like graphs that have all the parts? Why are we only making like the positive portion of a graph, the positive quadrant?
That's easier.
Because you can't have negative.
Would it ever make sense to, in this situation, have a graph like this? Like, is it ever going to be negative? Are you ever going to have a negative amount of bacteria? No, you could have 0. Are you never going to have negative time? No. So we only need this upper quadrant. Okay, so that's why our graphs are going to look like this. Okay, so on the bottom, on the x-axis is time, and on the y-axis is population. Okay, and your graph is going to look something like this. Something like that. Close to that. So, someone describe to me what is happening in the change in population over time.
Population.
Is it like steadily increasing? Is it increasing at the same slope?
So,
Is it getting faster as time passes?
Yeah.
Okay, so the way you would describe this is the population. The population is increasing at a faster pace or a faster rate as time passes. Okay, the population is increasing at a faster rate as time passes. This is actually something called an exponential growth curve. Okay, you do not have to worry about that for a couple years. I'm not sure. It used to be in Algebra 2. I think it's in like Math 3 now. So not for a couple years that you'll have to deal with these things, but that's called exponential growth. Do any of you guys unfortunately have experience with, like, have you ever seen mold like on a piece of bread? Okay, that's bacteria. It's like exponential growth. Like there's like nothing there, and then there's like a little spot, and then it like grows and grows and grows like really fast. Okay, that's called exponential growth. Okay, same thing with like population of bacteria. Okay, stuff like that. Okay, that's called exponential growth. Okay, let's do 2 more. I'm gonna flip the page. Is everyone done with these?
No.
Okay.
Yeah.
Well, you let me know when you're done writing, and I'll move on. Are we good? Okay. two more for number 3. So that's when I'm giving you, so those first two were when I'm giving you a graph and telling me to, or having you, excuse me, I can't talk today, write a scenario about it. This time I'm going to write a scenario and I want you to draw the graph, okay? Because I said so. So for example, number 3, I'm going to tell you an oven is being preheated. An oven is being preheated to bake a cake. Okay, I'm going to ask you to sketch a qualitative graph showing or to represent temperature over time. To represent temperature of the oven over time. Okay, so to represent temperature of the oven over time as a function of time. Sketch a qualitative graph to show temperature of the oven over time. So, hopefully we realize that we're only going to have the upper quadrant, okay? Where should temperature be? Is it on the x-axis or the y-axis? Temperature is this one. Okay, over time. Time is pretty much always time is going to be on the x-axis. So how would you draw that? Like if you're preheating an oven, obviously it's going to start at like 0 or whatever. So is it going to be steadily increasing? Do you think that the increasing part is going to be linear or non-linear? Should it be curved or will it be kind of straight? It's going to be pretty straight. Okay. Is it just going to keep going and being straight and straight and straight forever? Does it just keep going? Have any of you ever baked something in an oven?
No.
Did we want it to just keep going and going and going?
Until
The whole point of preheating is we want it to get to a certain temperature, right? And then what do we want to happen with that? You want it to stay the same. So you want it to get to a certain temperature and then you want it to stay that way. And that's it. You don't want it to keep going, okay? That will like burn up your house if your oven just keeps going and going and going.
I like it burnt.
Well, you can still preheat to a certain extent, okay? You don't want it to just keep going. So that's it. That's how your graph would kind of look. Okay, let's try one more, okay? So for example, number 4, do any of you guys live out in the country where you have like horses and, okay, does anybody have, okay, not that you guys care, but when I was growing up, we lived out in the country, and does anyone not have city water? Like, do you have to have like a well at your house? Does anyone, does anyone have that situation? Where like you're not like hooked up to city water, so you have to have like a well outside of your house, okay? So for example, number 4, it says a well is being dug. Okay, a well is being dug on a piece of land. Being dug on a piece of land. A well is being dug on a piece of land. The team digs at a constant rate. Constant rate here is basically saying that the slope is consistent. Takes a break for lunch. The team digs at a constant rate, takes a break for lunch, then continues digging at a slower rate. I would like you to sketch a qualitative graph that shows the depth of the well over time. And I promise on your homework, you guys aren't going to have to like write all these down. Okay? So, like I said earlier, time is basically always going to be on the x-axis. Okay? And here, this is going to be the depth of the well. So, if we said that the first part is going to be consistent, okay, or a constant rate, do you think, is that going to be linear or non-linear? Linear means constant rate means it will be linear. Should this start at 0? On your oven, we didn't start at 0. Why?
Because the room
It's
temperature.
already at a certain temperature.
Because it's already at a certain temperature, already at room temperature, okay? It's not at 0 degrees. Like when you first put something in your oven, it's not at freezing, okay? It's not at 0. It starts at a certain temperature. That's why we didn't start at 0, 0. It was not at the origin. But here, if we're talking about the depths of something, depth is going down, but you start at 0. We start at the ground, okay? So depth of your well says, okay, we did like that much. Then what happened though?
It's like flat. Oh.
They stopped, right?
Yeah.
So that over time, so for like lunch, they were like flat, okay? They did not dig anymore. Then it says we kept digging, but not quite at such a high rate. So that means the slope shouldn't quite be as high, okay? So it's going to be something like that. It's just not quite as steep, okay? And that's pretty much it, okay? So you guys do have class